Hello everyone, I am Anirban Garai, a student of Bulpur College under Bardwan University. I made my DSC4 presentation on chromatography describing its classification, principle and efficiency of technique and the mechanism of separation. So, chromatography is a technique used to separate and identify the components of a mixture. The chromatographic process occurs due to differences in the RF of the individual sample components. So chromatography is an efficient technique to separate, identify, and purify any component mixture. The RF value is the characteristic value for each and every component in chromatography. It is calculated by distance traveled by the sample divided by distance traveled by the solvent. So it is an general image of chromatography. After performing the chromatographic paper or plate looks like this. Chromatography works by allowing the molecules present in the mixture to distribute themselves between the stationary and a mobile phase. So the stationary and the mobile phase are the two most important phases. The stationary phase is solid, but the mobile phase may be liquid or gas. Now, describe about the classification of chromatography. First, according to mobile phase, liquid chromatography and gas chromatography. For example, liquid chromatography and liquid solid chromatography. For gas chromatography, gas solid chromatography and gas liquid chromatography. According to the packing of the stationary phase, paper chromatography, thin layer chromatography and column chromatography. Paper chromatography and thin layer chromatography are mainly used to identify, but column chromatography may be used as to purify or separate. According to the force of separation, gel filtration, affinity, ion exchange, adsorption, partition. Now describe. Now we will describe about thin layer chromatography TLC. So these are the two images of thin layer chromatography. The glass tank used in TLC must be covered due to absorb any disturbance made by airflow or gas molecules. After performing TLC, the TLC plate looks like this. By calculating the RF value retention factor, we can identify the different mixtures, different components present in a mixture. An important terminology in TLC is the visualizing agents or spraying reagent. After performing TLC, the components are sprayed with the visualizing agents. The components perform colorful compounds with these visualizing agents and we can easily separate them. If we want to separate between different types of alkaloids, we must use Dragendorf's reagent. If we want to separate and identify sugar, different types of sugar, aniline phthalate should be used. And to identify different types of amino acids, ninhydrin may be used as a visualizing agent. Now, describe about paper chromatography. So these are the two general settings for paper chromatography. The paper chromatography is based on partition coefficient, which is calculated by C stationary by C mobile. C means the concentration. Now, describe about column chromatography. Here, the stationary phase is packed into a column. So, it is a general image of column chromatography. So, these are the different terminologies in column chromatography: solvent, eluent, retention volume developer, effluent, and eluate. First, solvent. Mobile liquid phase with no affinity to the stationary phase and no effect on the solutes are the solvent. For example, ethyl acetate hexane. Developer, for example, petroleum ether. Developer is any liquid with more affinity to the stationary phase than the solvent but less than the solutes and just capable to move them through the column. Now, effluent. Effluent is any liquid that passes out the column. Eluent. Example of eluent is ethanol, water, pyridine. Any liquid that has lesser affinity to the stationary phase than solutes but is capable to move them out of the column is termed as eluent. Now eluate, fraction of eluent containing a required specific substance. Now the retention volume or a retardation volume, volume of mobile phase that passes out of the column before elution of a specific substance. Now move on to ion exchange chromatography. By ion exchange chromatography, the ions of an electrolyte solution are brought into contact with an ion exchange resin. The resin is a polymeric organic substance. For a cation exchanger resin, the negative charge is generated due to the CW minus ion, and for an anion exchanger resin, the positive charge generates due to NR3. The cation exchanger resin is itself negatively charged, which attracts the positive ions. Anion exchanger resin is itself positively charged and attracts the negative ions. Ion exchange resin or ion exchange chromatography has some impactful use in our life. For water softening, separation of lanthanoids, see hard water made by calcium, magnesium, sulfide, chloride, these ions. So we can easily separate the cations, calcium and magnesium, by using an cation exchanger resin, and the anions sulfide and chloride may be separated by the anion exchanger resin. So we can get soft water. Lanthanoids are also separated by using cation exchange by using an cation exchanger resin. So that's my presentation and these are my references. I am greatly thankful to our principal Dr. Nursad Ali sir, also our coordinator sir, and my supervisor sir and all the teachers of our department. I am also grateful to the non-teaching staff of our department, to my parents and my well wishers and my friends. That's all. Thank you, everyone.